Now, as we have said that we have the line drawing algorithms in OpenGL, and these are the three of them. We have the Bresenham's line drawing algorithm, and the DDA, the digital differential, and also the midpoint line algorithm. In this case, I have said that we will cover the Bresenham's line drawing algorithm, since it's quite widely used, and also I've seen it actually quite examined, because it's not that hard to get to, and it also works well. So you'll see how we can do it. So I hope everyone can see my screen. So if you can just react with some reactions if you can see my screen. Some reactions. I hope you can see my screen. Okay, okay. Yeah, so thank you for that. So we will start with the main function. So we said that the main function for when it comes to OpenGL is actually different from what we have, but I don't think you'll be told to be writing it, because it's quite some work. It's what we call some boilerplate code. So it's code that it's much code that it's just normally repeated, so it will never change. So what changes is maybe when you want to clear the color or set the window size. But now what I'm writing the main function, so we say int main, and then int argc, and then char. So these will never change. So these are character pointers. You don't have to worry about this. Okay, then this is now the main function. So you normally say glat init, and then and where is my and add gcc, whatever you've passed, argument gv, and then glat display mode. Then you say glat single, and also this is the color, glat RGB. So we said the colors, we're initializing that our application will use all channels of our color, which can be either red, green, or blue. So this is what will be used to. So if I can comment, I can say that this will be used to initialize it will initialize the GLUT library, and in this case we are initializing with the red and green and blue. So that means we can use color. So whatever we display, we can now use the color, and so that will be these two lines. So will initialize. So you can see this one is called init. It will always be used to initialize the glat library, and after initializing you can now set up the color. So you can now set the display mode, and now the display mode is what you're saying is glat single. I think it's about buffering, single buffering, and also the colors. We can have the glat RGB, the RGB colors. So the next thing that we need to do is now set up glat display mode. So this one is normally you initialize, so it's glat init display mode. So this code will never change. You don't have to worry much about it. Nobody will tell you to write all this code, but I just want for you to understand how everything works and how we can write our program maybe from scratch. So the next thing is to set the you set the window size. You recall us doing the window size, and this explains, or it will be used to set up the size of the window. You saw last time that we could set different sizes. So if it was like 1080 pixels, we would have said 1080 times 1920. If it was 720 pixels, we normally would say 1280 times 720. So to set the window size, you say glat init window size. So you can see it has the function itself, and you have to give it the width and the height of the window size. So maybe we can say we need 500 by 500. So 500 pixels by 500 pixels. So that is a square. And the editor is telling me it needs a semicolon at the end. So after creating our window, you can give it a title. So give the window a title. So a title. So glat create window. So this will give it a title, and a title we can say Bresenham's line drawing algorithm. Okay, so that is our line drawing algorithm. And then we have to give it a color. Give the window a color. So you can be asked, which is the piece of code that gives the window color? And the code that gives the window color is, you say GL clear color. Okay, so that is what will be used to give the color. So you can set it in terms of the first parameter being red, green. So if you set it at 000, these two normally represent the RGB values. Okay, they will represent the RGB, because here we started with red, green, and blue. These will start with the RGB. So I think you can also say glat green RGB. Okay, RGB, so glat red. So these are the different types of colors that you can specify. RGB. You can also set the RGBA. So the A here, it stands for what we call the alpha. So alpha, it can be represented as the, what do we call it? We normally call it as the maybe transparency. So when we say that clear color, so in this case, if we specify all of them to be zeros, it means that it will be, let's say, black, clear, like black color. Now a full transparency of 1, it means this is the alpha now. The 1 is what we have called the alpha. And then you can give the drawing color. So this is the color that now will be used to draw. So we have set our background to be black. So in this case, the background is black. Now, when we want to draw our lines, we also need to set the color of those lines. So let me just get rid of these warnings. So what I can do is say define GL silence deprecation. So let me do that right up here. So to just get rid of those warnings. So to define something, you say hash define. And I think these should go. So they are not as shouting as much. Yeah, so we now want to give the drawing color, and now to give the drawing, there they have actually gone. So now to give the drawing color, you normally say glat or glu, and then use the function for ortho. Okay, you can see gl ortho to d. So double left, right. So 0, then 400, then you can start with 0, 400. So I think I can run this code so that you can be seeing what we are doing as it just goes on. So let me just run it. I don't think it will run because we haven't written the display function. So let's write the display function. Now this is the display. Call the display function. So we said that we have to call the display function. And for the display function, it's a special function now that will be used to display. So glat display function. So now this has to be a function that we will create down here or up here that will be used to display our what do we call it, our shapes or our OpenGL program or thing. So we have to have the display function, and for the display function is normally called the void display. So we have created a display function here. This is what we call the display function. It's called from the main function. So that display function has been called for the main function. So these author today, it's actually used to set up. So we started window size, and then these will be used to author 2D will be used to set up the coordinate system of the window. Set up the coordinate system for the window. So think of it as where will it start? So if we are doing our x and y coordinates, how will they be defined? So maybe x will start from 0 to 400. Y will start from 0 to 400. So think of it as that. So let me just write the function so that you can see glue author 2D double left, right. So you can see left, right, then bottom and top. So you can think of the left as x, where it will start, then right where x will end, which it will be 400, and then bottom where y will start, and then top where y will end. So that is the coordinate system for our window. And now we say that here we call the display function. And to call the display function, you have to name it the same way that you have called it here. So we normally call it display itself. So you just say display. Okay, so you just say display. So now that is the display function, and then we have the code that will always remain. So to ensure that it's always displaying, we have to have a loop so that when the code ends executing, it may continue infinitely until you close your application. So until you close your application, that is when the code will stop running. So we normally have the main loop. So you just say glat main. I am writing it as a comment. Glat main loop. So that is just a single glat function that let me comment it and say that uh, this is normally the glat infinite loop. The glat infinite, um, it's normally called infinite event processing loop. So this is an infinite loop that will always make sure that our OpenGL program, like it runs, uh, as long as it hasn't been closed by the user. As long as you haven't stopped your computer maybe from running, this is what makes the glat main loop to run, and then you just say return 0. So that is this is how we write the main function, but I don't think someone can tell you to write all these. I just wanted to write it for you, explaining every single line of code so that you can maybe understand. So now for our display function, here is where now the magic happens. So to display, in other cases we were displaying something like a triangle, something like a line, something like a line loop. So in this case today we will be trying to actually draw a line. So the algorithm itself, we will actually write it in its own function and call it in the display function. So we can say that GL clear, then GL clear, uh, it's just a standard code. So these are the things that will never change. This will be just used to clear the color buffer bit. Color buffer bit. So the color, I think what this does, it's if there was any color that was defined in the buffer. So let's say the buffer is maybe a frame that hasn't been displayed yet. So if there was a color that was present and it hadn't been displayed, just clear the display buffer. So that is what that GL clear does. And the last thing that it does, we normally say in our display function, you have to have the what do we call it, GL flash. And what does flash do? Normally what flash does, it will flash the OpenGL commands to ensure they are executed. So the GL flash command, it will ensure all the OpenGL commands, all the commands that maybe you have written, or all the commands that needs to be executed, it will ensure that they have been executed. So that is its sole purpose here. So what we can now do, so now at the middle here, we can now implement the Bresenham's line drawing algorithm. So now here is where we can now implement the line drawing algorithm, our line drawing algorithm. And for this algorithm, we normally have quite a lot of what do we call it, quite a lot of points that we need to process. So we need to process how our points are drawn from the start to the end. So we will have quite a lot of points. So the first point is for the x-axis and for the y-axis. So we have to have the start for 0, x0 and y0, x1 and y1. So you can think of those as the starting point. So let's say the starting points. So we have x0 and y0. So to define x0, we say int x0, okay, and then int y0. So those are the starting points, and then we define our ending points, and those will be int y0 and no, not y0, y1, and int, it's normally good to start with x, so x1 and int y1. So this is the start of our line, starting points of the line, and this is the ending points of the line. So those are our starting points and also the ending points. So having now all those, we need to find the difference. Find the difference between the two. So between the two. So here is where you calculate the difference between x and y. So you calculate the difference in x and y, because we have provided the starting points and the ending points. So you say the int, first you start with the, let me comment and say this is the difference in x, okay, so the difference in x. So the difference in x, so we say int difference in x, so dx is equals to x1, so let's say x1 minus x0. So this is the end point of x and the end point, the start point of x. So that will give us the difference in x. But now since we are writing it now in code, we have to use the absolute value. So you say it's the absolute value between x1 and x0. So the ending point of x and the starting point of x. The same way for the difference in y. So you say int the difference in y is equals to the absolute value of y1 minus y0. And now in the Bresenham, in your theory, you learned that there has to be, what do you normally call it, the decision parameter and increment. So the decision parameter, it will be twice the difference between y, and x. So let me just write it in code so that you can see what I'm talking about. So you determine the decision parameter and also the increments. So the increments will be used to determine where the next point will be drawn. So let's see how that works. So the decision parameter p. So to find p, you normally say int p is equals to 2 times dy minus dx. So that is how you normally get your decision parameter p. So this is the initial decision parameter p. And then now for the increment, you determine the increment if we are moving horizontally. And if we are moving horizontally, we will use we multiply the y-axis by 2. So int 2 dy is equals to, so you multiply the y-axis by 2 times the dy. So that is the horizontal increment. And also if we are moving diagonal now, if we are moving now diagonally, we increment, so here we've incremented the y-axis by 2, the difference. So this dy, we got it as the difference between the absolute value of y1 minus y0. So now if we are moving diagonally, if our line is moving diagonally, if line is moving diagonally, we normally say it's you normally do it as 2 dy minus the dx. So you have to use both dy minus dx and then you multiply by 2. So you say int 2 dy minus dx. So let me remove something that has come here, of which is equals to this, just the same thing. So 2 times then dy minus dx. So this will increment moving diagonally. So let me check maybe the chat. Andrew, I see you have raised your hand. Do you have a question or something? So if you have a question, you can interrupt me or just maybe open up your mic. Okay, so now to increment, since we have set up our points or our how we need to be incrementing, how do we call it, how we need to be incrementing our points as we draw our line, we now need to have those now points x and y, and also define the end point. So we say int x, y, and also where our x will end. So the end point, one of the end points. So here is where we will determine. So we have to determine the starting point based on the x coordinate. So this is the x coordinate. So we need to see where we are starting at x and where we are starting at y. And for that, we will use the points that we actually got here. So these points, the x0, y0, x1, y1. So to define, if you want to start x0 at what? We start at 0, 0. No, I don't want to start at 0, 0. So I want to start at maybe 10, and also y to be 10. So that will start at x0 10, y0 10. And the ending point will be, let's say we want to draw a diagonal line from the point 10 10 to 100 100. So x1, let's say the ending point of x1 will be 100 and y1 will be 100. So this will draw a diagonal line from the point x0 10, y0 10 to x1 100 and y1 100. So these are the points that now will be substituted here for x. So we want to define this point. You see these x1, x0 and also x1 is a single point and use it as a starting coordinate. So we determine the starting point based on the x coordinate. And how do we do that? So we say we get to determine our starting point, we need to know which one is it. So you have to, let me just, if x0 is greater than x1, okay, so if x0, so we are determining whether x0 is greater than x1. So this will be used to determine our starting point so that our algorithm can know which is our actual starting point. So what we are saying if x0 is greater than x1, what do? We say that x is equals to x1. So x is equals to x1. So if x0 is greater than, so this one is x0 is equals to 10 in our case, and x1 is 100. So x0 is not greater than x1. So this one won't be executed. So let me just write the code and then explain. So here we say that we have to start from the smaller point, like we just start from the smaller point of x, and also we define our y. So our y will be y1. So that is the end point. X ni x1 and y will be y1. And then you recall here that we have said x end. So x end will be equal to x0, because here we are testing that x0 is greater than x1. So if x0 is the greater one, kumaanisha it's the bigger one. If a number is bigger, that means that is where our line has to end. That is why we are saying our line has to end at x0 if x0 is greater than x1. Okay, so like let me just comment that out and say end at the point which has the larger value of x. And we say that start from the smaller point of x. So now we end at the larger value of x. The same case here, we say that we want our end x to be 100. So you see 100 is greater than 10. So that is what we are determining here. So if x0 is greater than x1, do this. And then else, if it's not greater than 1, now do the exact opposite. So else, say that x is equals to x0. So you start from there, let me just comment that out. Start from the point of smaller x, and then y is equals to y0. Okay, so and then x end is equals to x1. So we will end at x1. So in our case, since this condition has been false, our loop will come here because our decision will come here, I mean, to will execute here. So end at the point which has the larger value of x. So our loop will come to this else statement because x0. So what is our x0? X0 to me, we have defined it here as 10. And what about x1? We have defined it as 100. So let me just write it out. So x0 is equals to 10 and x1 is equals to 100. So it will the decision, the if expression will come and ask itself, is x0, which is 10, so is 10 greater than 100? Is 10 greater than 100? I know that is simple, and the answer is no. No, 10 is not greater than 100. So this is false, and if it's false, go to the else part. So let me just delete this. So that was just to show you that our condition will come to the else part. So it will say that x is equals to x0 and y is equals to y0. So we have determined that our start and end points are x0 and y0, and the x end is x1. So now to draw a line, we say that it's points that are joined together. So we now have to draw all these points. So now draw the points to make up the line from start to finish. So we need to now draw the points. So to start drawing points, we use the GL begin function. Begin, so you know this, begin, and then you say GL points. So that will start our OpenGL, and we'll begin with the points. So let me ensure that everything is okay. And also let me, we're almost done with the algorithm. So after we begin, we have to start we have to use a loop. So we will use a loop that will now draw all those points. The loop will determine where the next point has to be drawn, and it will continue doing that until we get to the end point. So that is how the algorithm will work. So it will start from the beginning of, in this case, which we have said that our x0 will be 10 and our y0 will also be 10. So let's now start drawing those points. So drawing now is the last final bit of our algorithm. So we draw our first point. So draw the starting point, of which the starting point will start from x and y, which we have said it's x0 and y0. So to draw a vertex point, it's just the same way you normally draw. GL vertex to I, and then you specify the x and the y. So you say x and y. So that is the starting point. We have drawn the starting point. After drawing the starting point, we now loop. We now do a loop until the end point is reached. So you do a loop until the endpoint is reached. So the endpoint is what we were saying here as the x endpoint. So the x endpoint will be exactly the same as the y endpoint. So we will do a loop. So for looping, we learned this in C. So we have to have a while loop, and we say while x is less than the x end. So this will loop from the starting point of x and go to where the endpoint goes. So we have to increment x in every iteration. So increment x in every loop. So you say to increment something, it's to add it by 1, and to add something by 1 is saying x plus plus, or you can say x is equals to x plus 1. So x plus plus is what you call incrementing. And after you increment, you have to decide whether you want to move vertically based on the decision parameter that we named as p. So if p is less than 0, so this is what will determine whether you will move vertically or horizontally. So if p is less than 0, you say p plus equals, or you can say p is equals to p plus 2 dy. 2 dy. So 2 dy, it doubles the y-axis. So 2 dy, we named it here, we defined it here, and we say that 2 dy will multiply 2 times the difference in the y-axis. So that is why we are using it here. So if p is less than 0, that means that we have uh, to move vertically. Okay, then here is where we will update the decision parameter. And then if it's not, if p is greater than 0 else, so this means that p is greater than 0, you say that we increment now y, we increment our y-axis. So here we will move to the next y coordinate. And then after doing that, we say that our p is equals to p plus 2 dy minus dx. So this was the second one that we found on top here, and what was 2 dy minus dx. So it is that if the line is moving diagonally, so we increment moving diagonally. So that is why we are using both dy and dx to find the next diagonal point. So that is what will be done. And then after this is the last step. So here we are updating p, which is the decision parameter. So after doing that, we now draw the point. So draw the determined point. So to draw is the same thing, gl vertex to I, and then x and y, and that's it. So this draws the current point. So this will now draw the point after it has been updated, and oh, you can see it has quite a lot of math, but when you get the algorithm, especially how we update p, I'm sure you have this detailed quite well on your theory. I don't think you will be told to write the code. I think you'll be told to maybe calculate now manually how everything is working, and for that I know you have the algorithm on your theory notes. So let me run the code and see whether it can draw our line. So let me just run the code. So let me just run it and see whether it will draw a line. So imagine that all this code will just should just draw a line. So it's running. Yeah, the build is succeeded, and let me see. Not now. So I also need to share my window because I'm just sharing what do you call it? I'm just sharing a single window. P is equals to 2 dy. So let me just share my entire screen. 500 coordinate system. So let me just try to see whether I can have it as 400. So the window size, I'm trying to make it match with what we have for the orthographic 2D here. GL, RGB, single. So I'm checking whether everything is okay. And yeah, I think our code should have I returned glut main loop. This, we said that that was the main. So we start with the main function. So to just give a brief overview, so we start here with the main function, which has these two parameters, argc and argument v, argument c and argument v. So that will be used to initialize the glut, what do we call it, the glut library. And then we have the glut initial display mode, which will set the display mode to single, and also the RGB for the red, green, and blue if you wanted to use color. And then we have the initial window size. I will set the size to maybe 400 by 400. And then create window. We say that this is what will be used to now give a title. So our title should be Bresenham's line drawing algorithm. And now, so this will now be used to give the color. So we have said that this is a clear color because we've set it at 0, 0, 0, 0, 0. So we can just say maybe 0, 0, 0, and then 1.0. Yeah, so that now will be used to give a clear color to our window. And now this next will set up the coordinate system for the window. So we can say that it will start from 0, 0 to 400 by 400. And I have made the window size to also be 400 by 400. And then we after our orthographic, we just say that our display function is the function that we have written on top there that will display the algorithm. And then we will have the glut in our main loop, and we return 0. So what we do next is now go to the display function. So for the display function, here is where we have now said we will draw our what do we call it? Our Bresenham's line drawing algorithm. And okay, so vertex to I, GL flash. We also have to have GL end. So this is the while loop. So this is the loop that we have there. Then say GL end. So I had forgot to add this GL end function. So this is what this will do, will end the drawing points. So you have to say GL end and GL flash. So GL flash will ensure that all the OpenGL commands have been executed. And now we calculated our display function. So we started with the clear color buffer bit, and then we defined our starting points as 10 and 10, and our ending point as 100 by 100. So that means this will be a diagonal line. And then we calculated the difference in x, which is the absolute value when you minus x1 and x0, and the same case for the difference in y, the y1 minus y0. We have our decision parameter, which is 2 times the difference between dy and dx. And this one, if it's we are moving horizontally, this one where was the diagonal one, this one is now if we are moving diagonally. So we use 2 dy minus dx. So we say 2 times the dy minus dx, and then we determine our starting point for x and y and our ending point, and that will be determined by the first coordinates. We see which one is larger. If the first one is larger, we make it the end point. If the second one is larger, we make it the end point. And then we start drawing our points, GL begin, GL points. And then we draw the first starting point for x and y. So we say GL vertex to I, x and y. And then we do a loop from the start to the end point as we increment our x value, because this x value is what will be used to draw. So we are drawing GL vertex to I, we are using x, we are drawing x here. You can see here we are drawing x and y. So if we change x, that is what will be drawn. If we increment y, that is what will be drawn too. So we say that if our parameter, the decision parameter is less than 0, we add the decision parameter to 2 dy. And what was 2 dy doing? It was increasing horizontally. And then else we increase diagonally. So we add our p to move to the next coordinate. So we update p to a diagonal move. And yeah, that is how we update our decision parameter. And then we draw the line x and y, and then end, and then flash. We've said what those two do. So now what I'll do is now share my entire screen so that you can maybe see the output, see if our line was our line was able to be drawn from the points that we had specified. Yeah, so let me share my screen. Let me share my screen. Let me share my screen. My entire screen, because I'm pretty sure you can see the stop presenting, and then share my entire screen. So this is our line. So this is the line, so this is the window. Okay, so this is our window, and the line that has been drawn is right over here. This is our line that has been drawn. So if we wanted to make it maybe longer, we can increase the starting and ending points. So you just come here and say that our ending point are maybe 500 by 500. So let's run and see. Build succeeded. So you can see our line is way much bigger. So you can see it has actually drawn a diagonal line. So this line is just made up of different points. Okay, so all those points, they have been drawn one by one, and then determining which is the next point to draw using the Bresenham line drawing algorithms. And if you look at the top here, the title of our program is Bresenham's line drawing algorithm. Yeah, so that's about it, and that is the code. I think I'll be sharing this code too for you to maybe see. And yeah, that's it. Maybe now if there are questions for that, but I don't expect someone to tell you to write all this code in an exam or maybe in a CAT. Maybe for an assignment that I'll maybe give you, I'll tell you. So I'll tell you to write the code to now implement the other remaining two algorithms, the DDA and the midpoint algorithm. But I don't think you can expect this in an exam. For the exam, you will actually now calculate these points manually on like a table. So for an exam, that is what is normally tested. So you just calculate these points manually on a table. So you just have to know how P changes and whether to draw our point vertically or diagonally, and how everything increments or decrements. So for your assignment, you will have to now provide the code for how DDA works and how the midline algorithm also works. So by the next lesson, I'll come checking out for this, and also you will have to write it on a piece of paper or just print out. I will come collecting next lesson. So that will be your assignment. I think I'll write it down so that for those who maybe haven't attended the lecture, can be able to know what to do. So yeah, so for the code, don't expect you to be told to implement all these in an exam. It would be ridiculous. But I don't know. You never know. I have never seen it, but just know how it works. Okay, just know how it works and how to calculate it now manually. How to calculate all those points manually. It's actually simple theoretically when you know how to calculate the difference in x, the difference in y, and also especially how to do with the value p. That is where most now people get lost, how to determine p. So just know how it's done manually. Yeah, so for your assignment, you will have to implement the DDA and the mean point line drawing algorithm, and also write it on a piece of paper so that I can come collecting next lesson. Or you can also print, there's no problem with that. Yeah, so that's it for today. Maybe if there are now questions, I can stop sharing my screen. Someone is asking the IDE that I am using. So for my case, I am using an IDE for Mac. It's called Xcode. So I'm using Xcode. Let me type Xcode. Xcode. So it's normally for just Mac OS. So for code blocks, I don't, you just have to know how to just liaise with some of the students who have been able to set up code blocks in Windows, or some I have seen some of us who have been able to set up in Visual Studio too. Liaise with them, or also Dev C++. You can also follow the tutorials that I shared to set up in those three of them: Dev C++, Xcode, not Xcode, code blocks, and how do we call the other one? Visual Studio or VS Code. So yeah, so I think that's it for today. Anyone else who has a question? Okay, okay. So that's it for today. So just know how the Bresenham line drawing algorithm works in theory, especially in theory, how you can do all this math practically, or maybe on a table. So just know, ensure that you know that, ensure that you know that. Okay, so that's it for the lesson today. You can leave maybe for the next lecture. Okay, okay, thank you.